Hey everybody, I'm Craig Heffner. I'm a senior staff engineer at NetRise. Before we kick this off, just a quick show of hands. How many people here have ever received or created a software bill of materials? Excellent. I'm here to tell you they're useless. No, not really. But they are a problem. So we kind of liken them to nutritional facts when you go and buy something from the grocery store, right? This is a list of things that someone says is in the product. Most people have no way of verifying the validity of that data. And even if you did, how many people have the time, resources to go through every single thing you buy from the grocery store and check it when you get home, every single time you go grocery shopping? I don't, so I just kind of have to trust the label. But the reality is that what's on the label is probably not 100% accurate. Same thing with SBOMs. And that's not to say that people are intentionally disingenuous. They just don't know what's in their software. This isn't the 1970s anymore, where what runs on a computer is whatever you put on a punch card. We have a complex ecosystem of libraries, modules, dependencies on dependencies on dependencies, and it's really difficult to know what's actually ending up in a software product. So we have a really great team of people working for us. I've worked with several of these guys for the last 15 years, and we've all been doing this kind of thing for longer than we'd care to remember. And the one thing that we find time and time again with everybody that we work with, every single customer, is they'll come back to us and say, hey, you said we had product X, version X in our product. We don't. And we're like, yeah, you do. And they just have no idea. So I've got a couple of common examples that we see a lot here. So we had a customer who, submitted that one of their assets to us, ran it through our system, and they came back to us and said, bullshit. Well, they were a little more diplomatic than that. But they said, hey, you claim that we have OpenSSL version 3.0.0 on our system. And this has known CVEs associated with it. And I said, look, we can prove we don't have that. We ran RPM. We looked at our package manager, and our package manager says we have 3.0.7. We said, hey, whoa, wait a minute. We didn't say that the OpenSSL library installed on your system, system-wide, is 3.0.0. We flagged this in one of your Python modules. Sure enough, they went and looked at one of those Python modules, and they found evidence that it was, in fact, 3.0.0. And it wasn't just one file for Python. They had multiple versions of Python on there, all impacted by these CVEs. And they had multiple versions of Python installed. So they had a bunch of these installed on their system that they didn't update. So they updated OpenSSL system-wide, but these particular binaries were built against an older version of OpenSSL, and we're not using the system-installed OpenSSL. So we see this all the time. Things get statically built in. You're not aware of it. You see a CVE for OpenSSL. You're like, oh, we'll go update the OpenSSL library. And vendors just don't think what else is using OpenSSL that might have been statically built in. Another common one we see a lot is zlib. Very common compression library used all over the place. So we had a vendor send us a screenshot. Hey, you said we have zlib 128 installed. We don't have 128 installed. Once again, package manager says we have 3.1.1. And we said, hey, do you see the little file name down at the bottom of that screenshot? It's not pointing to libzlib.so. It's rsync, which, if you're not familiar with rsync, it's a very common binary for syncing files across networked file systems. Now, the interesting thing with rsync is they didn't build it statically against a library. rsync bundles zlib in its source code. And that version of zlib that's bundled is 128. And by default, it will build that code into the final rsync binary. Now, there are compilation options you can provide to tell it not to do that. But how many people even know that exists, much less make use of it? So this is another example of, if you're not really familiar with the code that you're compiling, and in a complex system, you're probably not really familiar with all the code that you're relying on and compiling, even if you're building everything from source, you can be introducing vulnerabilities. Even if you don't change any code, right? This is affected by a compilation flag. You could have 0 code changes, but just change one flag in your build process, and that'll change what version of some library is present on your system and what your risk is. So these, we kind of gave a couple examples here: static linking, build environment dependencies. But the other big thing that we see are dependencies on vendors. You probably use something from someone else, right? Most people aren't rolling all their own stuff. You've probably got vendors that you depend on. What do they have in their code? What are their dependencies? What are their sub-dependencies? What are their sub-sub-dependencies, right? This is turtles all the way down. The only way to really know what's running on your system is to look at the binary that's running on your system. It's as simple as that. It's the ground truth, right? The code that runs on a computer is the code that runs on a computer. It doesn't necessarily match the source code that you think is there or the dependencies that you think you have. In fact, 100% of the time it doesn't. Doesn't matter if it's some small real-time operating system based device that's only, firmware is only a couple of megabytes, or some 10, 20 gig image, full-blown Linux install. So when you're building your products, or when you have, someone you depend on who's building products for you, there's a lot of different things you have to think about. The first of, what libraries, versions are we going to use? Obviously, right? Let's not use something that has a known vulnerability at the very least. You have to think about, well, are we going to statically link or dynamically link? Now, I work on open source projects, and this comes up. In fact, I just had a bug submitted to Binwalk, and someone said, hey, you really should fix the build versions to what you're testing against. And it started this whole discussion, but I didn't even get involved. I was like, yeah, you guys duke it out. But I mean, and there's good reason to do both, right? If you're relying on library X and library X changes sometime down the line, it could change the API. It could make breaking changes to your software. Now all your customers are pissed because nothing works, right? If you statically build that in on a version that you know works, you don't have that problem. Of course, then if there's a vulnerability in that particular component later on down the line, now people aren't even aware maybe that they have that on their system. You've got to issue updates because people can't just update their local libraries on their systems. So there's pros and cons to both, but you have to be aware of the risks that involves. Like I gave with the example of zlib, even compilation flags can cause issues. You have to know your build environment. You have to know what changes and effects things are going to have on your system. And then if you're using some sort of build cache, right? When's the last time that cache was updated? What are you actually building against, right? You may not even realize you're building against something that's kind of old. So these are all issues where you can get stuff that creeps in, and you may be running source code analysis, right? That's great. Absolutely do that. But there are things that can cause source code analysis to miss critical issues. So I will not mention people by name, but this is just a good example here. Those two previous examples were from the same device, same vendor, same release. And it wasn't like we just found those two things. They had 47 hidden dependencies they did not know about. 14 of those were due to static linking. 3 were from vendor libraries. And 30 were caused by code getting compiled in at build time that they just didn't know was there. And source code analysis didn't find any of these because they had run source code analysis before they came to us. And again, not saying you shouldn't run source code analysis tools. These numbers would be way higher if they hadn't, I promise you. But it's an incomplete picture. And there's things that creep in that you just don't know. So we focus on binary analysis, right? We want to see what is actually running on the actual system. You cut this release, this went to production, what's actually in it. Now you can do this yourself, right? You can use tools like Binwalk to take a file system image, or even a single binary can have compressed data in it, archives, that kind of thing. Pull all that stuff out. Then for each of those binaries, you can search for specific version numbers for specific libraries. A lot of times these show up just in simple strings, right? Copyright text, a lot of times will tell you if a particular vendor has touched that code. You can look at symbols if you're dealing with stuff that has standard like ELF headers, PE headers, and that kind of thing. There's tools out there that'll tell you what they import, what functions they use from those imports. That's all useful information. You can search for vendor names. If you're like, hey, I want to know if we're using something from vendor X. Again, copyright strings. People love to put copyright strings in their code. You can just search for the vendor name. A lot of times that'll pop up. But this is really a tedious process, right? You have to do this for every single binary. You really have to know what you're looking for. You have to know how to validate and remediate any findings you do get. It really doesn't scale for anything other than maybe a hello world, right? So if you're on a security team and you want to do this kind of thing, hopefully if you're on a security team, I don't have to tell you this. If you find something that's unexpected, go for it, right? Unexpected stuff is exactly what security teams are looking for, right? But don't just dismiss them because whoever you're working for says that doesn't exist. Because 99% of the time they're wrong. It is there, they just don't know about it. Document your validation process. You're going to see things over and over and over again, right? Like the examples with rsync and Python. You're going to see those. So document your process, script it up, whatever you have to do to make your job easier in the future. If you're a developer, hey, keep doing source code analysis stuff. But when you cut a release, look for stuff that maybe you didn't expect, right? Look for version numbers. A lot of times they just show up as ASCII strings in the compiled code. You can grep for that kind of thing and get some idea of, oh, hey, that looks weird. I didn't know we were using that. Why is this version number not matching what I thought we had? Know your build flags, right? Again, this is probably, if you're on a big team, not going to be one person's decision, but you should know the risks and at least voice the risks of using different compilation options, building things statically, including third-party code, that kind of thing. And keep in mind that when there's something you need to rebuild, you probably need to rebuild more than one thing, right? If there's a vulnerability in library X, especially if it's a very common, popular library, it's probably present in more than one place on any reasonably complex system. So you might need to go through and just rebuild it all, especially if you're not aware of all the places that it might be popping up. For people in leadership positions, you're a manager, you're a CISO, you need to have people or someone who knows what they're doing with binary analysis look at your stuff before it goes out the door. This requires pretty intensive expertise, but there are plenty of people out there who do this. We're one of them. We have a lot of the best guys in the business, but you need someone who does it. Whether you build your own team, whether you outsource to someone else like us, you need someone looking at this. And you need someone who does it on a continuous basis, right? Every release that goes out, not just today because you're in the hot seat, but stop it from happening in the future. In terms of SBOMs, trust but verify, right? You may not know if all the dependencies are there from any particular vendor that you get an SBOM from. In terms of your own SBOMs, these need to be augmented with additional information like what build flags did we use? Did we use static or dynamic linking? That sort of thing. So anything like a manifest file, package manager, SBOM. These provide great information, but be aware, they're not the whole story. Far from it. Everything that you compile potentially has hidden dependencies, and if you create a product or you use a product, I promise you there's stuff in there you didn't know was there. There we go. You need to be looking at the binary, and you need to know that whatever you're looking at probably has shit in there that you don't want. And even if what's in there is innocuous, right? You're like, oh, I didn't know we had that in there, but you know, it doesn't have any CVEs. It's fine. Yeah, it's fine today. But if you don't know it's there, when a CVE comes out for it tomorrow, you don't even know that that's something that needs to be updated. So I know the previous talk, they were talking about, you know, time to patch. Well, your time to patch is going to be a lot longer if you don't know you need to patch. So if you can answer what's inside your software, you don't need us. But I'm willing to bet that you cannot answer that. I don't think we have ever had anyone be able to answer that. In fact, most people just give us a blank stare. Some people give us SBOMs, and then we come back with a new SBOM that has 30, 40, 50 different things that they didn't even know they had. So what we try to do is give people a better insight into their actual attack surface, into their actual risk, not only today, but tomorrow. Even if something we find doesn't have a CVE today, doesn't mean it won't be there tomorrow, and you need to at least be aware that it's in there. So if anybody wants to talk more about this, see a demo, set up an assessment, we've got a booth over here. Come see us. We've got great swag too. We've even got stress balls, which you'll probably need after we're done talking to you. If anyone's going to be in Boston for Cyberfire next month, we're going to be there too. I'm running a binary analysis workshop. Stop by and see us. And with that, I'll open it up to any questions. I either did a great job or a terrible job. No questions at all. All right, awesome. Well, thank you for your time.